welcome to Science with Safiyyah. So today we are going to be making tin dendrite. Tin dendrite is a metal tree that grows before your very eyes. And before we start, I am going to be telling you some safety rules just in case you want to do this experiment at home. You need to put on protective gloves and eyewear, like I'm wearing gloves and some safety glasses. You need to conduct the experiment on the plastic tray and always follow proper safety precautions when handling batteries. And this kit is from melscience.com and we are not sponsored by them. So let's get started. So make sure if you're doing this, you need to prepare four AAA batteries for this experiment. When you get the starter kit, you'll need to take the smartphone clip-on macro lens. And from the set, you'll need to take the battery holder, the bottle nozzle, some protective gloves. You need the red crocodile clip wire, the black crocodile clip wire, a pin opener, and a petri dish. And you'll also need to take the tin chloride. So first we need to remove the cap from this bottle over here, which we've already done. I need to pour 1 bottle of sodium hydrogen sulfate, which is here, into the NaHS hydrogens into the bottle of tin chloride. So you're just going to pour that in here.
I'll hold this for you.
We need to pour all of it in here. Oh, that noise is strange. It's very weird.
That's it.
I think that's enough.
Yes. Excellent.
Now you need to insert the nozzle securely into the SnCl2 bottle. So far it should be like...
Okay. Okay, good. That's it.
So far it should be like this. Then you need to put the red, as you see, yours should come with 2 red caps. So you need to put this red cap on top.
Make sure you close it properly. Yeah.
So then because you don't want an explosion.
That's enough. Because it's got a safety feature on it.
Now you must shake this bottle for 20 to 30 seconds. So we are going to start the timer in 3, 2, 1, go. And make sure when you are doing this, you download the Mel Chemistry app. It will help you a lot when you are doing all the experiments. In your first kit, you'll also get a VR headset, and I might have mentioned that before, but oh well. That's the ding. You need to return. So far it should be like this. Now you need to pour all of this solution inside here into this petri dish.
Okay, very good. Now don't sting it too hard. Don't leave it at the bottom so it doesn't. Yeah, excellent.
So now you
Let
need
it
to
come out
squeeze
slowly,
it
all of it.
into the petri dish. Well, this is very jiggly. Not jiggly.
Excellent.
And remember, each kit will come with the ingredients you need so you can do each experiment twice.
Very good.
Now we will get our liquid soap and we need to add 2 drops of liquid soap inside the solution. And make sure you do no more or no less than 2 drops because you don't want so many drops and you don't want this one.
And
2.
2. Excellent.
And then it'll make all of it go together.
Yeah.
Now, what you have to do is you need to attach 1 red crocodile clip and 1 black crocodile clip on the opposite sides each. And remember, when you're doing this, make sure you have adult supervision.
Yes.
Because you don't want
because
to...
we're using batteries, my dad is going to do...
And my dad is going to be doing this because it's better for adults to do it.
Yes. Let's do this.
And remember, you always have to have adult supervision whenever you do any of the experiments we're doing today. Now you pin them on. And you have to make sure they don't touch.
But we have to make sure that they touch the solution.
Yeah.
So now
what
we do is we take...
Now you need to make sure they're touching the solution. Now you need to insert all of your AAA batteries into the battery holder. And then you'll need to attach the crocodile clips to them. And make sure the black one goes with the black and the red one goes with the red. But you have to remember that they can't touch each other. Or otherwise you might have a problem with the experiment.
Mm-hmm.
And Dan, he was my dad because you need adult supervision, and I said that 3 times, but you can never be too prepared. Oops. Now you need to watch this grow. It's actually growing a bit from over here, as you can see. I can see it growing. And I'd rate this experiment a 5-star.
You'll explain the process.
Now I'll explain a bit about this. Batteries are basically electron pumps. They suck electrons in with their plus side and pump them out of their negative side. When such a pump is connected to a solution via electric hoses, a variety of chemical reactions can take place by the electrode. Some particles will capture the electrons that are pouring out, and by the plus electrode, some particles will give their electrons away. In our experiment, the ions Sn2+ will gladly accept some electrons at the wire and will turn into metallic tin. Meanwhile, the plus electrode itself, which is made of iron, will give some of its electrons to the plus wire, leaving some ions floating around. This is why the red crocodile clip will eventually dissolve if you don't disconnect it. So now, if you want, we will be able to watch a video. Oh, I need to do my password. Yeah, I can do it. Now we are going to be watching a video all about this.
Did you get some great tin crystals? So what exactly happened on the molecular level? Well, tin chloride is made of ions, and in water, these ions will dissociate from each other to give us positively charged tin ions and negatively charged chloride ions floating around. When we have charged particles like these ions floating around, we call it an electrolytic solution. And that's just a fancy way of saying that the solution will conduct electricity. That's why we attached our electrodes to the petri dish, which were connected to a source of electric current, so that electricity could start flowing through the circuit. Now, we may have heard that opposite charges attract, and that's exactly what happened next. The positively charged tin ions were attracted to the negatively charged electrode, and when they got there, they found some electrons and were reduced to form neutral tin atoms. Once tin atoms are neutral, they no longer like to be dissolved in the water. They would rather form a lattice of tin atoms by themselves. And that's exactly what they did. One by one, neutral tin atoms joined together to make this incredible crystal structure that looks kind of like a tree. So we can use electrolysis to make a tin tree. What else can we use it for? We can use it to prevent certain metals from being damaged by corrosion. And we can certainly use it to produce lots of other metals besides tin, including very common materials like aluminum. So next time you use aluminum foil to wrap up your sandwich, remember the electrolysis we performed here today to make a tin tree.
So this is how it looks so far. So let's say we wanted to move this. If we moved it, all of this would end up going. So let's say we moved this from there. all of them would end up going over there. My dad will show you. And you almost broke the tree. Be careful when you're doing this, kids.
Yes.
Make sure an adult does it for you.
Dad is very clumsy.
As you can see. So let's say we moved it there. Now all of this over here, as you can see, will start going all the way to this one. Because opposites, they'll always attract.
Yes.
So this is the end of our...
Following the...
This looks very pretty right now. And a bit strange. So this is the end of my first video on science with Safiyyah. I hope you all enjoyed this, and we will be having another video tomorrow. And I'm not going to tell you what it is because it's going to be a surprise. So bye bye. I hope you enjoyed, and I'll see you later.